Hey everyone, I'm asmollizard and today we get to dive into my mind actually to solve this RI 2020 Prelim Paper 1 question 11. So do give it a shot if you haven't, and I'll see you guys in about 3 seconds. Alright, so here's how I'm gonna do it. Context matters when it comes to these type of contextual questions. Important clues might be hidden inside. So we have a square base ABCD, and we know that AB equals to A equals BF equals to EHS ACM. So here is A, and there must be A because it's a square base. They told you that BCGF and ADH are inclined at an angle at theta radians is basically by figure 2. And AB, FE, and DCG here are perpendicular. So basically AB, FE, this trapezium here is perpendicular to the base. So they've also kindly given us the right angle triangle, a right angle there. So first part showed that the volume VCM cube of the content is given by that. So basically how to find the volume, it's quite simple, right? It's a trapezoidal prism. You have the length A, you just need to find the area of the trapezium. So the area of trapezium, you have it like this, okay? So now that this is A, you don't need to find this side here. You need to find the height as well, all right? But how? You know that you're given this as A as well. So how do you find the height? You're also given that it is perpendicular to the base. So if that is a right angle, well, what I'm gonna do is, here is a right angle, there is a right angle. Now, why must we find both sides? There is a chance where this side here is shorter or longer than the second side. But in this case, because, well, you notice that they said the same things, right? Theta A and theta. So they are similar triangles. So actually, you just need to consider one part here. Because you draw these two lines, this is A, let the additional length be B and the perpendicular height be H. You notice that if this was theta, the outside angle was theta based on figure 2, right? That means the inside angle must be theta as well. So from here, you can just use your trigonometry, all right? If let's say you can't think of it this way, or if let's say you're stuck, always look at the expression. You're given trigonometry, you're given that it is perpendicular. Likelihood, going back to the very bare basics of the first time we learned about trigonometry, right angle triangle, and comparing adjacent, opposite, and hypotenuse. Alright? So I wouldn't hold you guys up too long, so I'm just gonna write down the different values you need to get. H is simply A sine theta, B is simply A cosine theta. Now you're gonna find the volume, which is simply just the length, A here, and then multiplied by the height, half A sine theta. Okay, half times the height, so I combine both of them together. Now the double lengths, A plus 2B, so 2A plus 2B. This is cosine theta. So simplifying everything, you'll get back whatever the sum there. Just simply factorize out 2A from the last factor, and you get 1 plus cosine theta back. Alright, so this is part I is pretty simple. Using differentiation, okay, so this is differentiation, find the maximum value of V in the exact form. Alright, so clearly you're going to differentiate with respect to theta, because A is a constant. You don't differentiate with respect to a constant. A cubed remains as A cubed because it's a constant. Now we settle sine theta and all that. So first, how I do product rule, differentiate one first, so I get back cosine theta, then I times the other factor. Alright, so 1 plus cosine theta. Now I differentiate the other factor. 1 plus cosine theta gives us minus sine theta, hence I change the plus to a minus. Sine theta times the original factor, another sine theta. You then get A cubed cosine theta plus cosine square theta minus sine square theta. Alright, now from here there are two different ways. You know that if you're very familiar with trigonometry, this gives you cosine 2 theta. So you get A cubed cosine theta plus cosine 2 theta. Alternatively, you can kind of do it the other way where you notice, hey, this is a making of a quadratic equation in terms of cosine theta. And you can convert minus sine square theta to cosine square theta minus 1. And I'm going to show you that way to give us 2 cosine square theta plus cosine theta minus 1. Alright, then you factorize it. Simply cosine theta here is plus 1, yep. And then 2 cosine theta minus 1. Alright, so how I do it very fast, basically it's just a mix of experimentation. All right, 2 times plus 1 is 2, minus 1 times 1 is minus 1. 2 minus 1 give us the constant 1 down there. All right, so from here, dv d theta equals to 0. You have cosine theta equals to minus 1, theta equals to pi, or you have cosine theta equals to half, you have theta equals to pi over 3. All right, so when you have two options, what do? You go back to the restrictions in place. Theta being an acute angle between 0 and pi over 2, so you get to reject d theta equals to pi, and please don't forget to give your reasoning for your rejection. So you know that theta equals to pi over 3. All right, now for those of you who went through the route of cosine 2 theta, you get back the same thing actually. You just do the factor formula, cosine 2 theta in the MF26, and then you'll get the similar answer right here. All right, so whatever it is, both paths lead to the same answer, same conclusion. So what we do next is first find that, or rather prove that v will be a maximum at theta equals to pi over 3. So if you want to differentiate this, either you use a second derivative test or you use the sine test. I'm going to use the second derivative test, but instead of using cosine squared theta, I'll use cosine theta plus cosine 2 theta to give me a cube minus sine theta minus 2 sine 2 theta. Alright, this simply gives me minus a cube. And then sine theta plus sine 2 theta. Now, because from here you can actually conclude very fast that is this will be less than 0 because theta is between 0 and pi over 2. Sine theta plus sine 2 theta is bigger than 0. And therefore minus a cube is less than 0, so everything will be less than 0. Alternatively, and the really preferred method is just put theta equals to pi over 3 in. So you just put at theta equals to pi over 3, and then you get a certain value that should be negative as well. So from here we know that v is a maximum. From here, put that theta equals to pi over 3 in the original formula because they want you to find the volume. So remembering the formula, a cubed sine theta times 1 plus cosine theta. So this simply gives me this root 3 over 2, this 3 over 2, 3 root 3 over 2 a cube cm cube. Alright, so we've kind of proven part 2 and done part 2 already. Now we move on to part 3. A particular container is constructed with theta at pi over 3, the maximum value of the volume, and it is filled with water to half its height. Now, here's the trick. Half the height does not mean half the volume, because if you notice, the bottom half is clearly way less than the volume on top. So what do? Do the same way, right? Find the height, find the new height, find the new length on top, the new v's. But there's already a quicker way, all right? Because you notice that if you look at the trapezium again, let's just look at one of the triangles since both triangles at both ends are the same. So you notice that, hey, it's similar triangles, right? A becomes a over 2. B will then become b over 2. Why? Because you went from h to h over 2. So this divided by half will cause everything to be divided by half. Alternatively, because you know that it's a special angle pi over 3, you can think of it as going from the special angle triangle. If this is pi over 3, this is root 3. This is 2. This is 2, and then that will be 1. Alright, so you can use it from here, then you times h and all that. But I don't recommend this, alright? It takes kind of a longer way. Alright, so from here you know that, hey, the new height, let's just call it height 1, equals to now your a over 2 times your sine theta, right, which is sine pi over 3. So a over 2 sine pi over 3, we know that is root 3 over 2. This is simply root 3 a over 4. Your new b, let's call it b1, is simply a cosine pi over 3 over 2, 1/4 a. Your new volume, the length is still a, right? This length is still a. So we have a times your half your height. It's a bit messy. Then the sum of the two lengths. So 2a plus 2b, 2b is now half a. So from here we have a cubed root 3 over 8, 5 over 2. So this simply gives us a cubed 5 root 3 over 16. Now, explain if it's possible to tilt the container to the position for any water flowing out from the container. Alright, so what did it tell us? Before that, because it's kind of weird right now. Oh, it makes the same angle with the horizontal surface. You know that this was pi over 3. So if originally it was pi over 3, you tilt it. Basically, the sum of these two angles must be pi over 3. Right? Because it's now landing on one edge. As such, if these two angles must be pi over 3, this angle is definitely pi over 6. Alright? And what the issue is that you want to find the volume before the container, or rather before the water overflows. And we know that the maximum water it can hold is basically in this triangle down here. So how do you find the volume? Same idea, but now it's a triangle. Now it's the area of this triangle. Let's say we give this triangle alpha times the length, which is still, again, this length here, a. Alright, so what is the area of this new triangle? I'm going to do it right here so it's easier. So this area of the new triangle, you have the two sides. So either you find sine theta, but here you have the two sides which are adjacent to one another. As such, we'll be using the cosine rule, and we can find this angle down here, right? Because if these two angles add up to pi over 3, this angle is 2 pi over 3, 120 degrees. Alright, so using the area, or rather this is not the cosine rule, well, alright, this is the sine rule. Alright, the half AB sine C, not base times sine. Alright, I kind of mixed it up, my bad. Alright, so half AB sine C, so half A square sine pi over 3, because it's 2 pi over 3, it's the same thing. So I get root 3 over 2. So area, rather the volume we have is A times all that. So root 3 over 4 A cubed. Alright, so this is the length and then the area of the triangle. Now, what is it possible? Okay, so obviously this is a yes or no. So now how much volume do we have? Which is 5 root 3 over 16. Right, so clearly this is bigger than, or rather this is less than 5 root 3 over 16. Right, because this equals to 4 root 3 over 16 a cubed. Which means one thing. This triangle here will carry a lower volume than the amount of water we already have. Therefore, it is not possible. As maximum volume it can hold now without spilling or without flowing is root 3 over 4 a cubed. Alright, so that's how we do this question, and that's what's going on in my mind in my lizard brain.